Hello, everyone. Welcome to join our talk today. Today we'll talk about KubeEdge deep dive about the architecture, use cases, and project graduation updates. Okay, first, let's have a brief introduction for our speakers. Please.
Okay, good afternoon. I'm Wei Huan from Hongbing Cloud. I'm doing the work on the products design and the developing of the edge computing, and also I provide solutions for our customers who, yeah.
Okay, thank you. I'm Fei Xu from Huawei Cloud. Now I'm a full-time maintainer of KubeEdge, which is a CNCF graduated project. Okay, let's start now. Okay, first let's see. This is the KubeEdge project journey from scratch. You can see first we create this project, then donate to the CNCF as a sandbox. Yeah, then we release the V1 releases. Then we have the large scale use cases first. Yeah. Then in 2020 we became a CNCF incubation project. Yeah. Then we create the Sedna sub-project, which is a Edge AI project in KubeEdge. Yeah. Then we have several use cases like the vehicle, satellite. Yeah. Then we do some large-scale tests. Yeah. And in the last year, we have become the CNCF graduation project. Yeah. KubeEdge is also the first graduation project in the edge scenario in CNCF. Okay, this is a brief project journey for KubeEdge. Okay, this is the KubeEdge graduation celebration in the last year. Yeah, we have do some discussion for the future of the project. Okay. We also select to every member in our community. Okay, next I will introduce some project backgrounds for the KubeEdge. Yeah, from this diagram you can see from the right side is the cloud, then the regional edge, then the city edge, then near side edge. You know, many devices run in the near side edge, and many data also generated in the near side edge. So how to manage the node and the application in edge is what we want to do. Okay, this is overall introduction for the KubeEdge project. Yeah. You can see KubeEdge is the first cloud-native edge cloud computing OS project. Yeah, we have the open governance. Yeah, we also have many stars at Fox or GitHub. Yeah, we also have many contributors from all over the world. Yeah, from many organizations. Okay. Okay, next I will have an introduction for the project. Okay, you can see this is a KubeEdge architecture. Yeah, from the diagram you can see KubeEdge includes three parts: the cloud part, edge part, and the IoT devices part. Yeah, from the cloud we use the Kubernetes master. We don't make any modification for the Kubernetes master. Yeah, the right side is the cloud core. Yeah, this component is we developed in KubeEdge. Yeah. Because we think the network between the cloud and edge is always unstable. Yeah, so we have to do some enhancements between the cloud and edge for network issue. Yeah. In the edge part, we have the component edge core. Yeah, edge core, we integrate the light kubelet. Yeah, light kubelet is we remove some unused feature in the kubelet, then we integrate it in the edge core component. Yeah, right side we also develop some function for the IoT devices management. Yeah, you can see we can use the component called mapper to connect the IoT devices to the KubeEdge cluster. Okay, yeah, this is the overview of the KubeEdge architecture. Yeah. Okay, next I will introduce the latest release of KubeEdge, yes, we released many new features like support batch edge node process, like edge node batch join in, yeah, like IPv6 for cloud edge communication, and also multi-language member framework support. Yeah, this is for the IoT devices management. Yeah, also we upgrade Kubernetes dependency to the latest version. Okay, also have the new release of KubeEdge dashboard. You can see this is an overview of the dashboard. Yeah. Okay, next I will introduce the detail of the KubeEdge architecture. You can see this is the edge architecture, mainly for the edge application, edge pod, how we manage the edge pod in the edge node. Yeah, you can see above is the cloud part. Yeah, we send the pod metadata from the WebSocket protocol. Yeah, in the edge node, we use the edge hub, receive the metadata. Then we store the metadata in the edge store. Then send the data to the HD Kubernetes Lite, then run the container in the edge node. Yeah. Okay. Next is the IoT devices management. Yeah, we define an interface called the device management interface in the edge. Yeah, it can manage the IoT devices connected to the edge node. Yeah. From the Kubernetes master, we use the CRD to define several APIs for devices like device model and device instance to manage the IoT devices in the edge node. Yeah, we can manage the edge device connect or collection of data of the devices. Yeah. Okay, next one is Edge Mesh. Yeah, Edge Mesh is a network sub-project in KubeEdge. It can solve the edge application communication in the edge scenario. Yeah, because you know, in edge scenarios, the edge node can't connect to each other directly. So we built the Edge Mesh. It can help the edge application connect to each other in different sites. Yeah. Okay, this is Edge Mesh. It includes like the DNS function or other. Yeah. Okay, next is security in KubeEdge. Yeah, you can see KubeEdge is one of the first SynSafe project reaching L3 of supply chain level. Yeah, and we also have the full audit report. Yeah, we also KubeEdge is one of the first SynSafe project integrating with fuzzing, and we also released the threat model and the security protection analysis. Yeah, this is security updates. Okay, next I will introduce the Edge AI. Yeah, maybe many developed want to learn. Yeah, first you can see this is the Sedna. Yeah, Sedna is a sub-project in KubeEdge. Yeah, it's a Edge Cloud Synergy AI framework. Yeah, from the diagram you can see this is the overall architecture. Yeah, it also includes cloud part and edge part. Yeah, in cloud part we have a component called Global Manage. It has all the Edge AI task management, task coordination, and model dataset management. Yeah, this is the cloud component. Or we also have another component called local controller. It runs in the cloud node and edge node. It's the bridge between the cloud and edge. Yeah. The right side you can see we have a worker. Yeah, worker is the AI task run in the node. It can run in cloud and edge. Yeah. We have another called lib in the worker. Through the lib, the application AI workload between edge and cloud can do some collaboration for like joint inference and federated learning. Okay, this is a brief introduction for Sedna. Okay, next I will introduce the cloud edge joint inference. You can see what is Cloud Edge joint inference? Yeah, you can from the diagram you can see we have the devices like the camera, then 3 edge node, edge 1, edge 2, edge 3, and 1 cloud node. Yeah, we can deploy the shallow model, small model in the edge node, and the deep model to the cloud node. Then developers can do some, users can do some inference from the edge node. Yeah, when the confidence level is unmet, the request will forward to the cloud. Yeah, if the confidence level is met, the edge node will return the result. Yeah, this is the Cloud Edge joint inference. Okay, next is case studies. Yes, Juan, please.
Oh, okay, now let me show some cases that can highlight the power of KubeEdge. First, we have KubeEdge in the commercial vehicles, and as we know, commercial vehicles like trucks often operate in the remote areas where the signal loss is a common issue. However, for the better fleet management and the maintenance, the reliable network connection and the better vehicles management is very crucial. This is why KubeEdge. This is where KubeEdge comes in. So by enabling vehicles to run the AI models locally, KubeEdge can make them to identify potential issues before the problems occur. So in this way, the benefits is that even if there's no cloud access, the vehicles can run the models smoothly, and this can help our customers to reduce the maintenance costs and to do the better fleet management. Next, we have the KubeEdge in the offshore oil fields. Oil rigs are often situated far from land. So the network between the oil rig and the cloud is often very weak. Machine failure in such an environment can be not only dangerous but also costly. KubeEdge addresses these challenges by handling data on site. So the benefits are our customers can work in a safer environment, and the oil field systems can remain stable, even if there is no network connectivity between the oil rig and the cloud. And finally, we have a case about KubeEdge on the CDN. And as we know, content delivery networks are working on the delivering of the content from the cloud. But sometimes they will suffer the problem that the connect is very weak, and so the downloading is very slow. So KubeEdge can help provide more efficient solution by some AI models. We can do the prediction of the traffic. So we can ensure that only the necessary content will be fetched from cloud. So with KubeEdge, the outcomes are faster loading times and fewer problems, and the improved performance of the CDN servers. And also we have many other cases in the different industries, like in the intelligent transportation and the smart energy and industrial intelligence, and also others. You can track these cases in our community. So I will deliver to.
Okay, thanks, Juan. Yeah, you can see this is the use cases in many industries, yeah, especially in many traditional industries for KubeEdge, yeah, like the small energy, yeah, smart CDN, and smart campus, and smart logistics, yeah, and so yeah, you can have a look. Okay, next let's see the KubeEdge community, because KubeEdge is an open governance community. Yeah, first let's see this is some governance model in KubeEdge. Yeah, from the diagram you can see we have the TSC. About below the TSC we have some subcommittees and special teams, and we also have many SIGs in KubeEdge. Yeah, every SIG have many sub-projects like Sedna in SIG AI, yeah, and Edge Mesh in SIG Network. Yeah, we also have many working group like the MEC working group. Yeah, and so yeah, this is our TSC members and several SIGs and working groups. Yeah, this is a open governance model for KubeEdge. Yeah, next you can see this is some partners for KubeEdge community. Yeah, we have many partners from across industries, yeah, academic and research. Okay, next you can see we have many activities in the community, yeah, like the Linux Foundation, LFX. Yeah, we have many mentees from all over the world. Yeah. This is activities. Okay, in our website we also have the partners. Our partners provide like the solutions for the consumers. Yeah, if you want to find the providers, you can check the partner part in our website. Yeah, we also have many case studies in our website. You can also have a check. Okay, that's all what we introduced. Thank you. Do you have any questions?
I have one question relating one specific use case. Yeah. In our company today, we have sometimes thousands of workstations connected to the cloud-native backend. Have you already deployed KubeEdge on all workstations to take benefits of the computing power provided by all workstation, for instance, during the night when the employee are basically sleeping, in order to spot bots and exploit and use the power of this thousands of sleeping workstation?
Yeah, KubeEdge is mainly manage the edge node located in many places from the central cloud. Yeah, yeah, we have the Kubernetes master. Yeah, this is our control plane in the cloud part. Yeah, we can manage the edge node in many places that we think the network between the cloud edge is unstable. Yeah, this is the main scenarios. Yeah, KubeEdge focused on.
Okay, but this edge could be the workstation themselves?
Yeah, yes.
Okay. Okay, thanks.
Welcome.
Hi, I just want to ask, you have this case study on offshore oil rigs, right? And normally I think the internet connectivity and all is very constrained there. How do you manage your day two operations after it is deployed in production? How do you manage the security updates, new version updates and all? Because they also probably have a lot of regulations or I would say the longer life cycle expectations that they can't just allow you to have an update coming every 6 months or 18 months. How's your experience with the day two operations on after deploying it?
You mean the pod after deploy in the edge node? Yeah.
In the production, right? So that's a project deployed on oil rig facility. The case study you have.
So do you mean the case regarding the offshore oil rigs?
Yes, that one. And what I am assuming that you have deployed this in production, it is running there. But
Yeah.
after, let's say, 6 months, you have to put an update. Or do you have internet connectivity constraints? Does customer says that you only have this window when you can update it? You cannot do it like every 6 months or 3 months.
So KubeEdge is designed to address these challenges, especially on the whereas the weak internet connectivity between the edge and the cloud.
Okay.
And as we know, the oil rigs are often are situated far from land. So, but the machine in the oil fields are very important. We need to keep this machine running smoothly, and we need to identify any potential risks before the problem occur. So, in this case, we developed some AI models to do the predict of the problem. So because KubeEdge has a very important feature we called autonomy. This means even if there's no cloud access, the KubeEdge components will remain very stable and keep running. So all the edge applications, edge pods, they are running in the edge will keep running, even if the edge nodes, even if the OS is restarted, then all the pods running on this node will become normal in seconds. So in this way, we can predict the potential issues before any problem occurs, and then we can do the more effective oil rigs operation and maintenance. Yeah.
Okay. And what about the cybersecurity compliance? You have regulations and all you need to certify for deploying in oil and gas industry? Or do you get KubeEdge need to be certified by this cybersecurity authority or something like that to deploy? Yeah, just cybersecurity, any kind of compliance requirements in oil and gas?
You mean the container isolation?
No, like getting certification saying that, this system complies what you deployed based on this kind of industry certification on cybersecurity and things like that? Is that kind of requirement?
And often in the oil fields, they have their own private networks.
Okay.
Yeah, so this can ensure the network, and also we have the security the very secure communication mechanism between the edge and the cloud. We have the TLS connection.
TLS connection.
Yeah.
Okay. Well, thank you.
Hello. I have two questions. One question is like you tell about like robotic. What kind of robotic you meaning? It's like for example, ROS, like the robotic operating system, or it's something else? And second question is about this device management integration. Do you have like use cases? Someone use it with the automation, like the PLC stuff, or in manufacture, something like that, maybe?
Yeah. The second question for the IoT device management, we only define some APIs through the CID from cloud. Yeah, we can use API called device instance and device model. Yeah, these two APIs can control the edge IoT devices to connect to the KubeEdge cluster. Yeah. Then for the collect data, it will depend on the third-party application deployed in the edge. Yeah.
Okay.
Yes. Yeah. For the first question, can you repeat again?
Like what kind of robotic do you think? Like there was like information about extending KubeEdge to the robotics.
Mm-hmm.
And for example, we use our robots with the ROS system. It's like the robotic operating system. It's like the used for the manufactured robots. So basically, I asking if robotic you mean by some manufactured robots or like the human new kind of new age robotic stuff.
Yeah, actually we have some projects for the robot in our community. Yeah, they manage the robot from the central cloud. Yeah,
Okay.
they run the edge core component in the robot, then the control plane in the cloud. Then we can manage the application in the robot.
Okay.
Yeah.
Good. Thank you.
Welcome. Okay, any questions? Okay. Thanks for your time. Thank you. Yeah, if you have.